Grade 12's exercise 7, question 4, time to get our 3D-ness on. And picturing these, there's an art to it, I must say. And, hopefully you've got more than just this video, because to show this 3D, I wish I could just, build a 3D model, but let's see how we do. This shaded part is the bit that's on the plane. So if we've got a piece of paper, that shaded part is the plane. And then it says that CD is a vertical tower, so it's going to stick straight up. So there's a right angle hidden in the diagram because it's sticking straight up. So let's see where that right angle is. The right angle is between, there's a little right angle. So here's the tower and that's the ground. And then there's another one on this side, because if there's the tower, oh, great drawing that. There's the tower and there's the ground. That'll be another right angle triangle. Okay, so there are two right angle triangles. There's the one, there's the other, which means in this top triangle, that's 90, that's x. There's a 90 minus x up here. And I don't think we're going to need it, so I don't want to clog up the diagram. It's going to get messy enough as it is. And in this triangle, DCB, it's another right angle triangle, so we could use kind of sine, cos, tan straight up. Now, another thing that we're given, another bit of information, is that DA equals DB. So if we look at the front triangle, so there are quite a few triangles in the diagram, right? 1, 2, 3, 4. But if we look at this triangle over here, DAB, DAB is an isosceles triangle. And in that, we're told that this angle here is y, which means that this angle over here is also y. So there's DAB. And initially, when you get into these questions, sometimes it's useful just to start redrawing these diagrams, or at least redrawing the triangles, so you can see, hey, this front triangle, that's what it looks like. We've got that is y, this is y. But as you go along, you want to just picture it all in that 3D image that's given, or the 2D representation, I should say. So here we go. I'm going to remove that and that and that, because there's now one of the art or the skills here is how do we fill up all of this stuff in our diagram without making it too messy. This angle here is angle y, which means that we know that this top angle in the triangle facing us is 180 minus 2y. Again, little quick sketch separately as you're getting into it. That's y, that's y. The top one's 180 minus 2y. Just looking at it as a normal 2D triangle. A, B, D. Okay, so that means that we can work, we can use the sine rule there, we can use the cos rule, whatever we like to work in that triangle. Now, I'm laughing because I love these. There's so much thinking we've got to do. It's beautiful. So in this triangle here, in triangle DAC, so there's DAC. This is a right angle, if we remember. Here's C, and I've kind of drawn it with the funny angle, although of course it is just a right angle triangle if you viewed it from the right perspective. You've got K over here, and you've got X as that angle. So we could do things like tan X is DC over K, opposite over adjacent. Sine X is DC over DA, because it's just a right angle triangle. So the line now that's joining, can you see DA is in this triangle, and the little scribble triangle we did earlier was, that's not D, was ADB. So AD is in both of these triangles. So now that's the line segment that joins the triangles that we saw before. Okay, so with all of that thinking, let's revisit the question, what it's asking, what work we need to do. In the diagram, A, B, and C are points in the same horizontal plane. That means that I was saying that's kind of the floor, right? The shaded part is always going to be the floor or the ground. CD is a vertical tower. That's what we said meant that these two are right angles at C because it's sticking straight up. The angle of elevation from A to D is X. So this angle, if you kind of were standing at A and you looked across at C, you'd be looking straight, but you're looking up to D, and that angle there is X. And DBA equals Y. There's an isosceles triangle in AD equaling BD, so they've given us that angle A is also y, and therefore angle D is 180 minus 2y, and AC equals K. Prove that AB equals 2K cos E cos X over cos X. Right, so the question is where to start. Let's start in the triangle that we know the most information, and that's going to get us into a second triangle. So in our triangle, our first one, DAB, we could use the sine rule. And we said that we've got AB, we've got AD, and DB. So let's just set something up here and go any order, because I don't quite know where we're going, but AB was the subject of the formula, so I'm going to put that top left. AB over sine of the angle opposite, 180 minus 2y, equals, pick another side because it's an isosceles triangle. I'm going to choose AD because that's going to be our common side to the bottom, because we need to somehow get a K variable in here, which is in this triangle. So AD, that's our joining line segment, over sine of y. Now, you might have done a few of these already, and you can start seeing which things are going to start cancelling out. So AB should be the subject of the formula, is AD sine 180 minus 2y. I'm just going to show every extra step just in case we need it, over sine y. Now, sine 180 minus 2y, we've done something like this, cast diagram, second quadrant, that's just the same as sine of 2y. So I'm going to simplify it here so we can keep a lot more in play. And sine 2y, well, we can just use our double angle formula and say, wait, sine 2y, I'm going to change and write as times 2 sine y cos y. Because, lo and behold, those things cancel really nicely. And we did one of these earlier. Go back and watch it if you need to. Equals AD cos y. So it feels like we're almost there, right? We've got AB, we've got cos y, and we need to just work out what AD is. And hopefully AD turns into this, because then, you know, it will turn into what things are trying to turn into, if that makes any sense. But hopefully when we manipulate and substitute, we'll get there. So let's have a look here and see if we can work out what AD is. Well, we need to work with cos x, and there needs to be this variable k involved. Well, let's work on this triangle over here, this right angle triangle, and work out what cos x is. Well, cos x is adjacent, which is k, over hypotenuse. Well, that's cool. We wanted to replace AD. So AD needs to be the subject of the formula. So multiply both sides by AD, divide both sides by cos x, and we've got what AD equals. So now we can just put that in to that and go, well, AB equals AD times cos y. Hey, that's what it needed to turn into. Quite a lot going on there. And the key is just working in one triangle at a time. All we're doing is working in one 2D triangle at a time. But to see them in the picture takes a bit in the first go. Maybe I'm overstating it. Maybe you're like, that was pud sticks. Well, if so, great stuff. If not, even better, because you probably had more fun. I'll see you in the next one.